Okay, welcome back, and we are working on listing 3.434, and that was a what was that? That was an active high decoder, 2 to 4 decoder, active high, and we used the selected signal assignment statement, which is a concurrent statement, to implement it. And there are 4 outputs on that guy, and then there's 1 enable bit and 2 control bits, and then depending upon the enable and the control, we would set it to the respective values. Okay, so at this point we need to do a test bench. So what I want to do is come over here, select the project, okay, project, new source. Okay, let's create a new source. And we don't want VHDL module, we want test bench. Let's call this guy TB, and then what was our one called? It was called, let's see, decoder. Let's just give it the same name, but we'll prefix it with a TB, 2_4 for decoder. Okay, so we've got a test bench file. Next, and then which component are you going to declare and instantiate and test? Well, there's only one component here, and that's decoder. So we'll do a next on that. Finish. And what happens is I now have 2 files. I have the decoder 24 VHD that we did in the previous video, but now I have a test bench file. And again, since I have limited real estate, let's just get rid of all the comments. Okay, I'm going to keep this set of comments in there because I'm going to use that. Okay, now here's my entity. Okay, well, in a test bench file, the entity is always empty. Okay. Now, the test bench file has to instantiate a component. Which component are we instantiating? Decoder 24. And this is using the VHDL 87 format, right? Because anytime we instantiate a component using VHDL 87, we have to declare it. So the syntax of the declaration is just component and component, and then a port statement very similar to the entity that describes what goes in and what goes out. So you got to declare the component before you can instantiate it. Okay? Now, the test bench file says, okay, well, this component's got some A's, enable, an A input, enable input, and a Y output. So I'm going to create some local variables that I can connect to those. And I'm going to prefix those guys with TB just so you understand the difference between what variables are in the actual component decoder and what variables are local to this test bench file. Okay. And then we're not using any clocks at this point in the course, so let's get that out. Okay. And there's my declaration portion of my architecture block. Okay. Those are things we're going to use in the architecture. Now if we scroll down here in the actual begin end block, okay, this is where we instantiate it. Okay, now remember from class, this guy is using VHDL 87 format to instantiate component. Okay. And now we're not going to use any clock, so let's get rid of the clock process here. And here's my stimulus process. Okay, now we're still learning about processes, but the bottom line, outside of process, everything is concurrent. Inside of process, everything is sequential. So this is a process which is going to execute everything sequentially, not concurrently. And let's kind of gut it, and then what we'll do is we'll recreate it from scratch. Now this is just the name of the process, and that's, you don't need that. You can take it out if you want. Basically, a process statement has the process keyword, and then it has begin end process. There's something else there that we'll talk about later. Well, at this point, what I always do, kind of works well for me, is I end my process block with this assert false. So no matter what my timing is, I can actually zoom to full view and just see what I want to see. Okay. Yeah, so I would encourage you to put that in there regardless. All right, so that's the end. That's the last statement you want. Now, what we want to do here is we want to set up our test bench variables. Okay, but actually we got to go do some stuff first. We missed some stuff on the instantiation. Now, when you instantiate a decoder 24, the first variables are variables of the component. The second variables are variables of the current file, but you remember up here we changed the name of those variables. So we have to change them down here also. Test bench A, test bench enable, and test bench Y. And what I'm essentially doing here is I'm connecting wires. I am connecting these variables, TBA, TB enable, TBY of the test bench file, connecting them to the pins of the decoder component, A, enable, Y. So in the test bench I set the TB stuff, but this port map statement essentially connects a wire to the variables of the component. So all I have to do is set TB. So what I can do down here is I can say, well, let's disable the device. Okay, let's disable the device. It's a 1-bit quantity, it's disabled. And then what we'll do is we will run through some possibilities. And let's do this, 0, 0. Let's wait for 20 nanoseconds, and then what we'll do is we'll just go through all the possibilities. Okay, there's 2 bits on A, so this guy would be the 0, 0 possibility, this would be the 0, 1, this would be the 1, 0, and this would be the 1, 1. But notice the device is disabled. Nothing should happen. So let's copy this. I'll copy and paste that, but now what I'm going to do is I am going to enable the device. And now I'll enable it and do the same thing. Okay, so if you look at this code, the test bench, it's going to disable it, and then it's going to run through all the possible control inputs. Then it's going to enable the device, and then it's going to run through all the possible control inputs, and then it's going to assert false. Okay? So let's save that. Let's go over here, select our component. Let's check its syntax, make sure nothing's changed, which shouldn't have. Test bench file. Let's check its syntax, make sure I didn't make any typos, and we're good. At that point, select the test bench file, simulate, and we should get the output of a 2 to 4 active high decoder. 2 to 4 active high decoder. Okay, things are crunching. Here is my simulation output. Kind of shrink things down a little bit here. Okay, bring this back to here, and then say zoom to full view. And there you go. Look what's happening. The enable input right here is 0. Okay, so its enable is 0, which means it's disabled. So if I put a control input as 0, 1, 2, and 3, nothing happens on the output. Those 4 Y bits are all zeros. The 4 Y bits are all zeros. Right here, you can see Y3, Y2, Y1, Y0. Well, at 80 nanoseconds, I actually enable the chip. Okay, so now when I drive 0, 0, 0, when I drive 0, 0 on the control inputs, Y0 should be asserted, and it is. There it is right there. Okay, there's Y0. And then when I drive 1 on here, Y1 is asserted. When I drive 2 on here, Y2 is asserted. And when I drive 3 on here, Y3 is asserted. All right, so there you go. Yeah, so you can, actually we could kind of expand those guys, but if we want to look at this in binary, you can play games there. And then we could put this guy in binary, do some things there, but zoom to full view to get it back out there. Yeah, the device is disabled right here. Nothing happens. You always have 0, 0, 0, 0 coming off those outputs, Y0 through Y3. Here, at this point right here, right there, we basically enabled the device. So now when I drive 0, 0 into there, Y0 gets asserted, Y1 gets asserted, Y2 gets asserted, and Y3 gets asserted. And you kind of see you got this step function. Well, that's a typical output of a decoder. Now, if this was an active low decoder, all these guys would be 1, and the output that got asserted would be a 0. Okay, but it's an active high. All right, let's close this guy and do a little experiment here. What we're going to do is go back to my test bench file, and this guy right here is VHDL 87 format. Let's basically convert this to VHDL 93. Well, in VHDL 93, I do not need to declare things, right? All right, let's comment that out, because I don't need it in VHDL 93. So I'm going to basically take this guy, I'm going to Control C, I'm going to copy it, and I'm going to comment this guy out. And then I am going to make a little comment here that says now I'm using VHDL 93 syntax. Okay. Well, what was the syntax? You remember the syntax on VHDL 93? What was it? I think we had like a entity keyword, and then we had to tell it what workspace or library this guy was in, decoder, and then I had to actually tell it the architecture. Okay, well, what's the architecture? Now, let's go back and look at that decoder. The architecture was behavior. All right, so let's copy that, go back to our test bench file, put behavior into there, and then I'll bring this port map statement down on the next line, and there you go. And I think that's pretty much it. Yeah, so me switching to the 93 syntax is a little cleaner, right? Because I don't have to do this declaration, but I do got to add a few more keywords that aren't in the 87 format, in particular entity, work, and then the architecture type, but the port map statement is the same. So if I save all this, and let's go back and just check syntax on everything. We'll do our component just to kind of be on the safe side. Then we'll do our test bench. I should get the exact same thing, but all I did was switch from 87 to 93 format. And then if I select test bench, double click, and my output should be exactly the same thing. Let's scroll these guys back to here, zoom to full view, and there you go. Yeah, let's open these guys up. And yeah, right here, the device is disabled. Enable is equal to 0. Nothing happens on the output. The output is always quad 0. Here we enable the device. Y0 gets asserted. Y1 gets asserted. Y2 gets asserted. And Y3 gets asserted. All right? Yeah, there you go. We're good. All right, I'm going to stop right there. You might want to look at this and see if you can figure out how to make it an active low decoder. Okay. All right. We'll close all that stuff, and we